Hello everybody, today we are going to be working on something called box plots. Okay, these are also known as box and whisker plots. So that is also another name that you may refer it to. The reason why it's called box and whiskers is it kind of looks like a box that has whiskers coming off of it. But the term that we use in 6th grade math anyway is box plots. Box plots. Kind of hard to say. So I want to kind of go through how to set up showing you how to make a box plot. A box plot depends on 5 very important numbers called the 5-number summary. And what those numbers are is when you look at your data, you need to know certain things. You need to know the median, okay, which remember is also known as your quartile 2. You have to know your quartile 1, okay, also known as Q1. You have to know quartile 3, okay, also known as your Q3. You also have to know your minimum number, so that's going to be your smallest number, okay? And you also have to know your maximum number, which of course is going to be your largest number. All right, the reason why it's called the 5-number summary is because guess what? There are 5 numbers here. 5-number summary. All right, 1, 2, 3, 4, 5, median, quartile 1, quartile 3, minimum, maximum, all of those is a total of 5. There's 5 numbers you have to know in order to make a box plot. So let's first start off by finding the median, because if I start with that, I'll be able to figure out Q1 and Q3 as well. So first step to finding the median, remember, is to put your numbers in order from least to greatest. So that's going to be 5, 8, 9, 10, 11, 12, and then 14. I'm crossing my numbers off just to make sure that I got all of them in my list. To find the median, I am going to, one at a time, start crossing off the smallest number and the largest number at the same time. So there goes the smallest and the largest. I'm going to do it again, all right? Smallest, largest, gone. And I'm going to keep doing this until I'm left with one number in the middle. Smallest, largest, gone, and as you can see, I am left with one number here in the middle, and this guy is my median. So it's my middle number, so 10. So there's my first number that I need to know. After that, I need to find Q1 and I need to find Q3. Remember that this is your lower quartile and this is your upper quartile. All right, this is your lower and this is your upper. So when you go to find Q1, the Q1 is going to be the median of this lower quartile. So when I go to find Q1, I'm going to cross off the smallest and the largest in that lower quartile. And what I'm going to be left with, this number here in the middle, is going to be my Q1. So 8 is my Q1. Same thing with the other side here. I'm going to get rid of my lowest and my highest number in that upper quartile, and what I'm left with here, that number in the middle, is the median of the upper quartile, which will be our Q3, so 12. Now the last 2 numbers that I need to know is the biggest number and the smallest number, which is pretty easy to see. The biggest number in my list is going to be this guy right here, which is 14, all right? He is the largest number, so this right here would be my maximum. And then I need to know my smallest number, which is going to be this 5 right here. It makes it very easy when you put your numbers in order least to greatest. This guy is your minimum, okay, or the lowest value. So now I have all of the numbers. Let me write these down here in my list. But I have all the numbers I need to make a box plot. So let's go ahead and start with that. All right, the first thing that you need to do is mark your median. Your median is at 10, so I'm going to put a dot above 10 here, and through that dot, I'm going to draw a dash. My quartile 1 is at 8, so I'm going to put a dot at 8, and again, I'm going to draw a dash there. And my upper quartile, my Q3 is at 12, so I'm going to put a dot at 12, and again, drawing a dash there. Now what I'm going to do next is connect these 3 dashes together. like so. This is the box part of your box plot. There is your box. We'll talk about what that box means in just a moment. The next thing I need to do is mark my minimum, which is at 5. I'm just going to put a dot. I'm not going to put a dash through it. But I am going to connect this dot to the box. Okay. And then I'm going to put a dot at my largest, my maximum, which is at 14. And then I'm going to draw a line and connect it like that. So this is a completed box and whisker plot. All right, now you can kind of see why it also is called a box and whisker. You have your box, and then you have like a whisker coming off of each side of the box. All right, now what's really cool about these box and whiskers or this box plot is that you can tell a lot from the data here. First of all, a box and whisker plot, or a box plot as we like to call them, breaks your data up into 4 sections. All right, and I'm going to try to draw those 4 sections right here with this highlighting tool. Okay, each piece of data that we added to our box divides your box plot into 4 sections. And as you can see here, let me change the color of my pen. Let's do a light blue. This would be your section 1. So this is one section. Section 2, here's your second section. Section 3, sorry, my handwriting is not super awesome for this. And section 4. So you can see your 4 sections. Now what's really important about that is those 4 sections actually splits all of your data into percentages. All right, think about it. What percentage, if there's 4 of them, added together it gives you 100%. Okay, so think about quarters. All right, each one of these sections is 25% of the data. It's pretty cool, right? So all of the numbers that was in this data set here that we started with, so all of these numbers that were in the data set right here, all right, we have split them up into this box plot, and each one of these sections represents 25% of the data. So for example, 5 to 8, this is 25% of the data. From 8 to 10, this is also 25% of the data. From 10 to 12, 25% of the data. And from 12 to 14, another 25% of the data. So sometimes with the box plots, they ask you questions like, from 5 to 10, how much of the data does that represent? Well, from 5 to 8 is 25%, and from 8 to 10 is 25%. So that's 25 plus 25. From 5 to 10, that represents 50% of the data. Half of your numbers from your data set live between 5 and 10. So it's a way to represent how spread out your data is. From these sections, we can see that our data is pretty evenly distributed. Take a look at your box. Your box is the inner part of your data. So it is going to be your median, which is your middle number. It's also going to be the Q1 and the Q3, which kind of tells you where the middle of your data lies, is in this box. This box represents 50% of your data, so it tells you where the middle 50% of the data hangs out. So you can see that that data goes from 8 to 12. So that data is not super spread out. It's only about the distance of 4 spaces. So our data is very, very close together. You can also tell that if our lowest number in our data is a 5 and Q1 is an 8, from 5 to 8, that is not a big gap either. So the data is not very spread out. There's not a lot of outliers or anything like that. The data is very close together. Same thing over here at the top here, from 12 to 14, which is your maximum, your biggest number in the set. 12 to 14, not a huge jump. So that tells us that we don't have a huge outlier, that our data is very close together, that it ranges from 5 to 14. The range is actually another number you could pull from this data. I know my biggest number is 14, my lowest number is 5. I could subtract those and find out that the range is 9. So the whole box plot takes up 9 spaces. I can also tell what the IQR is because I know Q1 and I know Q3. Well, 12 minus 8 is 4. So that means that the IQR, the interquartile range, is 4 spaces, meaning that this middle data is not super spread out. So you can tell a lot of information from a box plot, especially when they don't give you the data. But we do have the data, so we can kind of see where all those numbers lie. Now what happens if they give us a box plot? Okay, so they give us a box plot, and we don't know the data. So I'm going to scoot on down here. And that's what happened here on the second example. Is they've given us the box plot, but as you can see, I don't know my individual points. Now that is a downside to a box plot. You cannot tell individual data points. All right, I know that this data goes from 52 to 65. Do I know if there's a 61 in there? I don't know. It doesn't tell me an individual data point. Box plots just summarizes the overall data. So that is a downside to a box plot. But let's take a look at all the information I can pull from a box plot. First of all, what's really cool is I can get the median from this box plot. I know that the median is going to be, whoops, I'm sorry. My pen did not want to turn on here. I know that the median is going to be this middle line right here. This is going to be our median. So we can actually see that our median is about at 56. So that is one piece of information that we can come from this plot. So I'm going to write that down here. We can see that our median is 56. I'm going to need the space up here. All right, and then we can also pull what our Q1 is. This right here is our quartile 1 or our Q1. Okay, so we can see that our Q1 is about at 54. It's a little more than 54. So my best guess here, I'm going to guesstimate like 54 and, I don't know, like 3/10. So we can see that our Q1 is roughly at 54 and 3/10. Again, you're using your best guess estimating skills here for this. We can also see what our Q3 is. Remember that this line right here is our quartile 3, okay? It's our quartile 3. So we can see that Q3 is at 59. So we can pull some data, all right? Now we can combine those two things together and we can know what the IQR is. Remember that the IQR is going to be from this line to this line. It is the distance in between. So this is your IQR. This is the range between those two numbers. Remember the way that we find the range is the interquartile range is we're going to subtract Q3 minus Q1. So we're going to have 59 minus 54 and 3/10. So 59 minus 54 and 3/10. And when we solve that, we find out the IQR is actually going to be 4 and 7/10. So we can figure out the IQR. From this as well, we can figure out the minimum. The minimum is going to be this guy right here. This is your minimum. That means that is the lowest number in your data set. The lowest number in our data set is 52. And also, if we can find the minimum, that means we can also see the maximum. The maximum is going to be this guy out here. So there's actually quite a lot of data that we can pull out from this graph. The maximum is going to be at 65. Now, if I know the minimum and I know the maximum, that means that I can figure out the space of, or the range of the whole thing. So we can figure out the range of the whole thing, which is going to be the distance from here all the way to over here, how spread out all of your data is. To find the range, remember that you take the maximum, 65, and we're going to subtract the minimum, which is 52. So we're going to have 65 minus 52. And so that means that our range is going to be 13. This is the, range. Not to be confused with the interquartile range. That's something different. Okay, so there's a lot of different data that we can pull out of here. We can also see how spread out everything is. For example, if I wanted to know, if I wanted to look at this graph and see how spread out everything is, remember I can divide my entire graph into 4 sections, each section representing 25% of the data. And when you draw these lines like this, it really helps you see how big the different sections are. You can see that these sections right here at the beginning of the graph, okay, from 52 to 54.3, 54 and 3/10, is a decent length, a medium-sized length, while the distance between 54 and 3/10 to our median at 56 is a very small space. So there is a small space there. And then we can see, continuing on, 59 to 65, that is a very big space, so the data is spread out a lot over there. So you can talk about how spread out the data is from this graph. So these are some things that you can pull out of a box plot. You cannot figure out what the exact data points are, unfortunately. When you look at a box plot, it does not tell you that information. So like I said earlier, I don't know if there was a 61 in the data. I can't tell the data from a box plot. Okay, it doesn't work that way. Box plot gives me an overall summarization of how spread out all of the data is. Okay, so I really hope that this helps with box plots. Box plots is one of the harder, I think, and personally, harder graphs to interpret and to understand, but hopefully this kind of clears up some of any of the confusion that you may be feeling about box plots. All right, I will talk to y'all later. Have a great day.